So today we are going to talk about another machine learning classifier or another machine learning classification algorithm. And the name of the algorithm is naive-bayes classifier or algorithm. So as the name suggests, these algorithms, the mechanism of this algorithm or the working flow depends on the Bayes theorem. So in any class or upcoming class, maybe we can learn something about the Bayes theorem. Okay, so this is the naive-bayes classifier. So let's try to introduce with naive-bayes classifier or classification algorithm, machine learning algorithm. So naive-bayes is a method, right? So as I told you, naive-bayes is a classification method based on Bayes theorem and the assumption of predictor independence. And the naive-bayes model is simple to construct and is spatially very good for huge data set. So when you are dealing with big data or when you are dealing with a lot of data, then maybe naive-bayes could be a very good model for the prediction or forecasting. And you can consider naive classification, or you can use naive classification algorithm if you have a large data set. I already mentioned. And naive-bayes classifier in machine learning process flow, how we can adapt naive-bayes classifier in the machine learning workflow or process flow. So we can consider an example. Imagine because of the current weather, right? A cricket match will happen or not. So suppose you have a problem whether a particular cricket match is gonna be held or not. So it might depends on the weather condition. So what you have to do, you need to classify whether players will play the match or not based on the weather conditions. So this is a classification problem because the outcome of the problem is the match is gonna be held or not, right? So this is like the yes, no factor. So this is a classification problem. So if you want to exemplify or if you want to solve this problem, classification problem, so you can use a classifier, and this classifier is called naive-bayes classifier or naive-bayes algorithm. So for that, here the example, what is the feature here? Maybe the feature could be the weather condition, right? So like uh, some threshold of the climatic variables, rainfall, temperature, precipitation, or some other climate variables or weather. And based on the weather condition, maybe you can decide whether a particular cricket match is going to be held or not, right? Like the India-Pakistan match or Bangladesh-India match. So you need to classify, okay? And by nature, this is a classification problem. So how can you solve this problem? Maybe you can try to apply naive-bayes to solve this problem for the accurate or uh, good classification accuracy, or to predict the occurrence of the match. You can use this kind of algorithm for the good predictive accuracy maybe. So consider another example. You can see like day number 1, day number 2, up to day 14. So there are 14 days, and the weather condition might be sunny, overcast, rain, right? A lot of weather condition you may be outlook, and the temperature. What is the nature of the temperature for a particular day, starting from the first day to the last day? That means 14 number of day. So the temperature might be hot, cool, mild, right? And the humidity could be like high, normal, right? And the wind speed, or maybe the wind may be weak, strong. So, and finally the tennis match, suppose, is gonna be held or not. So this is a binary classification problem. So because this is a machine learning problem, so you can apply the machine learning algorithm here, and also you can apply the logistic regression if you want. So you can just check the accuracy of each model. So I think naive-bayes will give you good accuracy rather than like the traditional approach logistic regression model. So you can use naive-bayes classifier algorithm. I think this algorithm is gonna be a good fit. But I can tell you everything depends on your data and the size of the sample and the characteristics of the data. If your data has problem, if your data has no definite pattern, like the COVID-19 cases nowadays, so a lot of COVID cases started like in the early onset of that particular disease when COVID was started in Bangladesh. As far as I remember, like the 8th March. So that time the peak or the incidence of the COVID-19 cases were very high, but at the middle point it's ups and down situation, and nowadays there is no cases. So what is the type of the data is very difficult to predict. Anyway, this kind of situation, maybe you can use the machine learning comparing to the traditional statistical methods. If you want to use the traditional statistical methods for this kind of problem, you might face a lot of problems like the overfitting, underfitting, and a lot of problems, so you need to manipulate or you need to adjust your model, especially your machine learning model. How can you do that? You can tune your parameter to maximize the output. So I am talking about the hyper parameter tuning. So you can tune the parameter so you can have the maximum output. Then by this way, you can select a model, and that model might be good fit to this kind of COVID-19 data. So it's very difficult to say like which algorithm is going to be the good fit. It will depend on your data, but you can check. You know a lot of algorithms now, and you can just check those algorithms with the traditional methods like logistic regression. So this is one example of naive-bayes algorithm, right? And so you can see there are two colors here, like three colors in fact: red, yellow. Which What is the name of this color? Sky blue, right? So three colors are here. So if you want to classify, so maybe you can use like probability. So this is the Bayes theorem, like the posterior probability and the conditional probability. So like the probability of dog given cat into probability of cat divided by probability of dog. Suppose these are some of the name of the color. Maybe I'm not sure, but consider these are the name of the color. So probability of dog, and given the condition is that is given cat into probability of cat divided by probability of dog. So based on this Bayes theorem mechanism, finally naive-Bayes classify. You see, this is the class one. That means clustering of one group of colors and clustering of second group of colors, and finally the last one. So how the naive-Bayes work? Naive-Bayes use the Bayes theorem, okay, to classify the objects or classes in the final classification. So this is the mechanism of working with naive-Bayes classifier. So this is another example like the same one. So posterior is equal to prior into likelihood divided by evidence. So in Bayes theorem, two kinds of probability is very important. One is called the posterior probability, and another one is called the prior probability. Prior means which one is like already given, and the posterior is means like you are about to calculate. So these two probability are very important to have a good understanding on Bayes theorem. So in Bayes theorem also you can apply the concept of conditional probability. So in one class, maybe in the upcoming class, I will try to give one lecture for the Bayes theorem. I think in that class you will be able to understand something about the Bayes theorem. So this is the Bayes theorem, like posterior probability. You are gonna calculate probability of C given X, right, is equal to probability of X given C into probability of C divided by probability of X. So this is the class prior probability, this is the likelihood, and this is the predictor prior probability, and this is the posterior probability. So this is the mechanism of the Bayes theorem. And you can also consider naive-Bayes as the principal component analysis. So what are the three components are here? So the three components, number one, number two, maybe the number three. So this is the dimensionality reduction. Like if you want to reduce the number of variables from a large set of variables, maybe you can use the principal component analysis. And naive-Bayes is kind of like doing the same thing. It's also used to dimensionally reduce your data set. That means you are going to classify, or you can do the clustering, right? You can do classification, you can do clustering, or maybe I'm not sure about the regression. You can check it whether naive-Bayes is supervised or unsupervised. So you have to check whether this is a supervised learning or unsupervised, and whether it can be used for classification, regression, and clustering. But today I'm going to talk about like the classification problem. Okay. So how naive-Bayes work? So you have first you have to convert the data set into a frequency table. Okay, so then create a likelihood table by finding the probabilities like play the match or not. So this is the likelihood. Likelihood is like the possibility. So what is the likelihood of the probabilities like play the match or not, right? So this is the likelihood. You have to create a likelihood table. Then based on the naive equation, calculate the posterior probability for each class. So how many classes are here? So there are two classes, like whether you have to play the match or not. So two classes, and you have to calculate the posterior probability for each class. The highest posterior probability in each class is the outcome of the prediction. So I can tell you the highest posterior probability in each class is the outcome of the prediction. That means you have to look for the highest posterior probability in each class is the outcome of the prediction. So it is easy to use and fast to predict the class of the test data set, right? And it performs well in case of categorical input variables compared to the numerical variables. So this is very important in naive Bayes. Like if your variable is categorical in nature, so naive Bayes is gonna be a good fitted model, machine learning model, comparing if your input variable is numerical in nature, right? So this is the main important like concept from here. It's required independent predictor variables for better performance. Like if you have low number of predictors, if you have low number of independent variables, it might occur like your prediction is not good. When you are going to increase the number of independent variables, then your prediction will be better. So this is the limitation might maybe for the naive Bayes classification problem. I told you again, sometimes the prediction accuracy you are gonna get from your analysis is not very good, like is not like satisfied at all, is not satisfactory at all. So what you can do, then you have to check the number of independent variables, that means input or feature. So you can increase the number of feature or number of independent variables, right? So I think then maybe somehow you can increase the predictability or accuracy of your machine learning model. Okay, so let's try practically with R programming. Okay, let's go to the R programming right now. So we are gonna use a classification problem again. So uh, you have to download the data from GitHub. So maybe you can check it later, the data, but I think you already know how to download data from GitHub, right? So a data download from right GitHub. So what is the data is like? So if you want to read the data or if you want to install, if you want to read the data or if you want to download the data, right? So maybe you have to use a library as I told you before. So what is the name of the library? Do you know anyone? Readr, right? This is the library and you can, now I'm gonna download the data. So I know the path of the file. So I can like just I write like this HTTP. What is HTTP?
Hypertext Transfer Protocol.
Exactly, hypertext transfer. So GitHub, right? GitHub. Oh my God. User content. Okay. You can just check. You can just take a look of this site. Main, right? Binary. So the data is about naive.csv. So this is a CSV format data, not the text file. So let's try with this data. Okay, I think it's downloadable, right? So now data, right? Sorry, data read under CSV and your file, right? So I think we already got the data. Let's try.
স্যার ওটা মনে হয় স্যার ইউআরএল ফাইল হবে মনে হয় স্যার, এর আগের দিন স্যার ইউআরএল ফাইল দিয়েছিলেন।
URL দিয়েছিলাম।
জি স্যার।
No,
ইউআরএল হবে স্যার, ওই যে প্রথম দিকে ওটা ইউআরএল ফাইল হবে, তারপরে এটাতে
yes, exactly. Let's try. Couldn't find the function.
উপরে স্যার এই যে ইউআরএল ফাইলে যেখানে লিংকটা দিবেন স্যার, ইউআরএল ফাইল হবে এটা।
Okay. Yes, that is very important. So I have to run it again, right? And let's try now. Couldn't find the read URL
এই যে
file.
এখানেও স্যার ইউআরএল ফাইল, যে ব্র্যাকেটের মধ্যে ইউআরএল ফাইল মনে হয় স্যার দেন নাই।
Good. That's good. Then
তাও তো স্যার প্রবলেম দেখাচ্ছে।
it's very difficult. You see, like if you just made some wrong, then it's difficult to read. Is it smaller case or uppercase? You see? Let's check now.
স্যার ডেটা ইকুয়াল দিছিলেন, ইকুয়াল আর এটা কি একসাথে সাথে কাজ করবে স্যার?
It's work already. You see?
জি স্যার।
So if you want to see the whole data, right? How you have to write s dot data frame, right? You can just frame it. You can just frame your data. Okay. Then you can see the whole data set are here. No? What problem? S dot data dot frame, right? The data, what problem? Yeah, good. So there are 95 observations are here. So as you can see, it's like how many variables are here? Number one is launch, then thickness, appearance, right? Spreading and ranking. So do you have any idea what could be the example fit for? Like I'm talking about, what is the example is about? Launch. This is the outcome variable, launch. Whether you are going to launch
cancer.
Launch
cancer.
Alina means what? Tell me, Koli, I cannot hear you. Koli, I cannot hear you. Could you please?
Sir, আরেকবার একটু কোশ্চেনটা যদি বলতেন।
I told you, can you guess or do you have any idea what is the data about? So I'm giving some, I'm gonna give you some clue, okay? So there are 1, 2, 3, 4, 5. There are 5 variables are here, right? Number one, launch, thickness, appearance, spreading, and finally ranking or rank. So this is the outcome variable, or this is the dependent variable, or this is the response variable, right? So the decision is like, or your response is like, or your dependent variable is like, the nature of the dependent variable is like, you are gonna launch something or not. So this is the clue.
Thickness, appearance, spreading, rank. Sir, I think it's any disease who is spreading, such like as COVID-19.
No. So what you are gonna launch then? What you are gonna launch then?
Oh.
Okay, this is a product. This is a product. So the response variable is product.
তাহলে thickness এখানে variableটা.
Wait. So there are 2 categories of the launch, right? So whether you are gonna launch a particular product or not, right? So 0 indicates product not launched, and 1 indicates the product is launched, right? So what kind of predictor influential observations to influence the launch about the launching of a particular product? Number is a thickness score, right? Appearance score, spreading score, and the ranking score. So there are many products you can just think about the thickness of that product. There are many products. You can look for the appearance of that product. There are many products. You can look for the spreading score of that product. You can have some idea of the ranking score of that particular product. So first variable is the response variable, and the remaining variables are the scoring. So these are the scores. So based on the scores, you are gonna classify whether you are gonna launch your product or not. So this is our today's classification problem. And for this classification problem, what you have to do? You have to use naive-bayes classification algorithm. Okay. So if we want to see the title of our data or the variable name, so you can use the head, right? Yeah, this is very easy. So data, I want to see the name of the variable, so you can just see launch, thickness, appearance, spreading, and rank, right? And um, if you want to see the dimension of your data, how many variables, right? So you can use also dimension team command, right? So how many observations and how many variables? So I think 95 and 5. So total 95 observations and 5 variables, right? So these are some of the basic analysis you can perform to take a look about your data. So for the naive-bayes classification, you need to install some library. Okay. You need to install some packages, sorry. So and then you have to load your library. So the libraries you have to use first of all library, right? So first of all naive-bayes. Okay, I'm just copying, then I can just put first library you need to install, you need to load is the naive-bayes you already see here, and the library is dplyr. Okay, and the third one is ggplot2. You already know this one, I think. Already everything is installed already in my computer, but I'm not sure about you. So if it does not work in your computer, what you can do, you can just install .packages. You have to install all the packages, then you have to load it in the library, right? So you see, yeah, I think every package is installed already in my computer. So as I told you in my previous slide, so what you have to do if you want to run the naive-bayes classification algorithm to solve your problem. So you have to do frequency analysis, right? So you have to identify your frequency distribution first. So let's calculate the frequency of the response variable under each rank, right? And the minimum frequency of each class you have to calculate also. Okay, so let's do some frequency analysis. So it's like frequency distribution. Okay, so suppose I'm x steps, right? X steps, then on where the response variable is launch. That is in just the variables you can, because you are calculating the frequency. So and the response variable plus you have to consider the rank, suppose rank. Why? You can just take a look and the result, I think you will understand today. Rank is not that rank, just rank. Okay, data is equal to data. Okay, so you will check it. You see the rank is here. So launch. So 1, 2, 3, 0, 1. So 0, 1 means like whether you are gonna launch or not. And the ranking variable, you will find how many, like 1, 2, 3. There are 3 rankings are there. So for ranking 1, how many observations in the category of 0 and 1 you got? 12, 21. For the ranking 2, how many? 21, 15, for ranking 3, 13 and 13. So this is the equal. So this is nothing but to find the rank, to find the frequency distribution of the launch variable according to the rank. So you can do the same thing with the other variables as well, because our concern is to calculate the response variable. That's why maybe we are interested to calculate this data anyway. Now we just look at each variable class based on the str function. You already know about the str. So what is the role of str? I told you to take a look in the Google. I'm not sure whether you check it or not. Anyway, you can just run this command. It's not that important. So now you can see that data. I think we already talked about the data. So 95 by 5 that I mentioned, like 95 observations and 5 variables, right? I think you already know about this one. So let's try with some ranking again. So rank s dot factor data. Right. So what you can see here, so you can just take a look what are the, like, so do you know what happened here? Any idea?
So ডেটাগুলোকে ডিফাইন করতেছি।
Okay, just we take a look again. Consider see the rank here. See the rank here, okay? 1, 2, 3. So this one, how 1, 2, 3 come? In the rank variable, you will find only 3 ranks are there. And this is nothing but the frequency of 0 and 1. That means the launch variable in each category, okay? So now what we did, don't know, okay, now check another variable, launch, right? So here it will be launch again. So data launch, sorry. So now run it again and take a look what happens here.
লঞ্চ হয়েছে কিনা 0 or 1?
Yes, but what I did here, you don't know.
I don't know.
How many observation we had in our data set?
So split করতে হবে কি?
I told you how many observation we had in our data set.
95.
Now how many observations now here? 89, 90, 91, 92, 93, 94, 95. 95. Right? Anyway, what I did here, you have to explore. Okay. Anyway, I want to tell you one assumption of the naive Bayes classification is that the independent variables are not highly correlated. So if the independent variables are correlated, what is the problem in econometrics? Can you remember? If you find the correlation among the independent variables, what?
Multicollinearity.
Exactly, multicollinearity. So there should not be any multicollinearity problem in the
Naive Bayes.
in your data set in the naive Bayes, right? So this is the classical assumption of naive Bayes, like the OLS, ordinary least square assumption. So another assumption is that you have to remove the rank column in this scenario and test the predictor variables association. Okay, so suppose you got the multicollinearity in your data. Okay, how can you remove that? You have to remove the rank column. You have to remove the rank column and test the predictor variables associations. So try to remove the ranking column or rank column. So you have to rank your data, right? Then you have to remove the rank column from your data set and try to test the predictor variables association. Then you can just check the association after removing the rank column. I think hopefully you will find there will no association between the independent variables, right? That means the multicollinearity is gonna be removed. So this is one way how can you correct the multicollinearity problem in your data set, and this is the assumption in the naive Bayes classification. So don't worry, let's try about the correlation now. Okay, so as we talk about multicollinearity problem, so now we can take a visualization. Okay, so how can we visualize this data? If you want to see the correlation here, how can we do this? Do you know any idea? Okay, I'm talking about the multicollinearity problem. So what is multicollinearity? Already someone told me, like, sir, if there is any correlation between the or among the independent variables, right? So you can conclude that there is a multicollinearity problem. So let me know what are the independent variables are here in our data set. Do you know?
Sir, spreading, তারপর
If you
হচ্ছে
don't know, let's take a look at the
appearance,
data again.
লঞ্চ বাদে বাকি সবই
thickness, appearance,
Thickness, appearance, spreading, and
spreading,
rank,
rank.
right? So
Yes.
now I want to check the multicollinearity problem. So how can I do that?
Correlation matrix.
Very good. Who told me correlation matrix?
Reza, perfect amount.
Raise. Oh my God. Very good. Mr. Warisul. Warisul,
Yes, sir.
what you have to do now?
Sir, bonus 2.
Okay. 2 or 5?
2, sir.
2.
2.
Okay, 2. You can give 2 to Reza. Anyway, so Reza, do you know how can I do this?
I don't know, sir.
Okay, normally we can do the correlation, but yeah, maybe if anybody take a look in my paper I just published, okay, the machine learning paper, you will find the similar graphs which I am going to construct right now. Okay, let's start with the correlation matrix. So like the checking, or maybe we can give a title, correlation checking. Anyway, so it's very easy, a single command. So what you can do, you are going to do some research, right, in the 4th year. So you can do this similar kinds of plot, so you can visualize your data. Okay, so this is called the like exploratory data analysis. So you have to explore your data in a very good way. Nowadays the research is no longer like the old fashioned, and research is going to be replaced with the new emerging technologies and visualization techniques. So this is one kind of technique, it's very popular, you can use in your research as well, right? So how can you do this? Pairs.panel. So because you are gonna have some panels, definitely, right? Panel, I think you already know this panel. So I think how many panel you will get here? Maybe four. How many variables? 1, 2, 3, 4. So maybe 16 panel you are gonna get here. Anyway, let's try. So will it work? Do you have any idea? If I just run this command, it will work or not? Okay, let's try. It's work. Okay. Did you see? Did you check? Can you explain somebody like what is this graph means, or what is this plot indicates you?
Correlation among the variables.
Try to summarize your conclusion. You have to take your decision from the whole graph. Okay, what is your conclusion then? I told you, like in my last couple of minutes back, I was talking about the multicollinearity problem. So if you want to take a decision very quickly, to just take a look from your graphs or from this correlation matrix, you have what could be your decision? You don't understand, right?
স্যার লঞ্চ আর থিকনেসের মাঝে স্যার কোরিলেশন বেশি।
Okay,
Sir, multicollinearity, sir, ওইভাবে নাই স্যার।
very good. So overall low correlation was observed. The conclusion will be like this: overall low correlation, low lower correlation was observed between the independent variables, right? Between. So you are comparing the pairwise correlation, right? Pairwise. So this one, this one, this one, this one, or this one, this one, this one, this one, this one, this one, launch, spreading, launch, rank, right? So, or thickness, because independent variables, right? Thickness, appearance, thickness, spreading, thickness, rank, right? So you have to forget about this one, right? We are talking about the independent predictors. We are talking about the independent variables because we are checking the multicollinearity problem. So this is not a problem here. Anyway, if I do some manipulation here, suppose, do you know what is this means? -1. What does this mean? You don't know?
Negative
sir.
correlation.
Perfect negative correlation.
No. I am just like edit my codes. It is my previous code, like data. Anyway, you have to check this one. Now you can take a look. What is the conclusion then?
Sir, একটা variable কমে গেছে।
Exactly. So there is no multicollinearity problem here, right? There is no multicollinearity. So this is the basic assumption fulfilled. So the basic assumption fulfilled. That means you can apply the naive-Bayes algorithm in this data set we are talking about, right? Anyway, so let's try with some other visualization as well. So box plot. You know box plot? If you don't know, let's
Yes,
try.
sir.
Okay, so ggplot we already installed, right, our package ggplot2. So you need to install this one, otherwise it will not work definitely. So x is equal to launch. Suppose in our x category we want to put launch variable, LUN, launch variable, right? Then what is the y? Tell me the y. Y is equal to what? Thickness, right? And fill, if I write the command like fill is equal to launch, what is this? What is mean by here? Fill is equal to launch. Don't know. Fill means color. You have to fill the color. That means the whole box plot will be colored. So fill, you are making a command, you are giving the instruction to our program like fill the launch variable, right? So this is very easy thing. Anyway, and the box plot, so this is the main command for the box plot, geometric maybe. Okay, and underscore box plot. Okay, the command is here. And the theme, you can use a theme underscore bw. You can use a theme here, and you can also use a title of the box plot. So how can you do the title? gg title, so gg title. So what you are gonna see as a title? So maybe box plot, right? So do you have any idea what kind of plot you are gonna produce right now? Can you explain, somebody?
Sir, the question again, please.
I told you, based on this comment, what kind of plot or what is the looking of the plot you are gonna see right now if I can run this comment?
Box plot পাবো ওখানে।
Yes, the box plot of what?
So thickness আর হচ্ছে লঞ্চের উপর।
Very good. Thickness and
লঞ্চের।
launch, right? So
Huh?
let's try now. Good. Could not find function g title. That means there is a problem in the command. It's not g, it's gg title. Okay, let's try now. You see? Okay, let's try to interpret this plot. Here the horizontal axis is launch and vertical axis is thickness, right? Thickness. And you see the color combination like launch 0, 1, 0 and 1. That means you launch your product or you don't want to launch your product. Could you please anybody like explain me this graph? Hmm? And I can recall, I can tell you again, like I can give you some clue. The clue is thickness score of a product. So you are judging whether you are gonna launch your product or not based on the thickness score. So now tell me, what is the interpretation of this plot? Oh my God. Do you understand? Hello. Hello.
স্যার শুনতে পাচ্ছি।
So you cannot answer, right? So I'm giving you another clue. Tell me 2.5, 5, 7.5. Increasing of what?
Thickness বাড়ছে স্যার।
Thickness scoring, okay, of that product. So the likelihood or the increasement in thickness, when the thickness score is increasing, what the decision? You can launch your product 0 or 1. What is this one?
লঞ্চ হবে
Launch. And what is this one?
thickness বাড়লে প্রোডাক্ট লঞ্চ হবে।
Exactly.
স্যার নাই নাকি? শোনা যায় না কিছু।
ওয়ারেসুল
স্যার
ইয়া
নাই,
ইয়া অফ
রেকর্ড
হয়ে গেছিল কেন যে রেকর্ড হচ্ছে।
স্যার।
ইয়েস স্যার।
Are you the host right now?
Yes sir, I'm making
Okay, let's try. I have another class, so I have to finish it very quickly. So yeah, so this is the interpretation, right? So maybe you can record. Are you recording now?
Yes sir.
Okay, so yes, so suppose now I am gonna repeat this one with the other variables, right? Suppose I am gonna do this using the appearance, right? Appearance, okay. Okay, so now tell me the interpretation quick.
Sir, if the thickness is increasing, then
Hey, where did you get the thickness? Bangamatar Sheikh Fazilatan Nasa.
appearance.
Yes.
Appearance.
The hall looks beautiful, lighting, right?
স্যার এমনিতে অনেক সুন্দর।
Yes, I'm talking about the appearance. So tell me about this interpretation.
স্যার প্রোডাক্টের অ্যাপিয়ারেন্স যত স্যার গ্লোরিয়াস হবে সেটা মানে কনজিউমারটা তত মানে নিবে সেই অনুযায়ী।
It's not the glorious thing.
সেটা তো লঞ্চ হবে।
The data is already given to you, and the data is about the scoring, appearance score.
স্যার
Yes, the more appearance score, okay, give you the more probability or likelihood to launch your product. Anyway,
launch the product.
exactly, and it's not that difficult. I think everybody can know this. So I am just also checks for what spreading. Okay, spreading score. And Kohli really doesn't understand what is the spreading score, but you can think definitely we'll have some answer. Anyway, what is this? What is the interpretation of this one?
স্যার এটা তো দুইটা এক নির্ভর করবে না তো
Anyway, try to think logically. Okay, statistics is about logic. Anyway, so let's go for very quickly. We can go for the prediction of our model. So now its main job to predict using naive Bayes. Okay, we already check our data. We already check some the basic assumption of the data to fulfill the assumption of naive Bayes algorithm. Now check about the prediction. So before prediction, what is the first thing you have to do? Data partition, right? So you have to split your data into training and test. How can you do this? Set.seed, right? Well, so you have to use a random number generator, and suppose I'm gonna define this variable. So sample, tell me quickly. You don't know. Hello.
Enrow.
Then I'm doing this several times, and you should
Replace.
understand of every coding. This is not my job
S equal to T.
Probability 0.
Probability equal to T.
7.
Okay, now
0.7.
I'm gonna change the probability. Okay, 0.8. Can I change? I can change this, no problem. Just want to see. Okay, is it okay?
Okay.
Okay. So what will be the train data set? Data from data, because already read our data, and what? And that variable I already defined here. Exactly equal 1, right?
1.
And what about the test data set?
Test.
Data.
Exactly equal to 2.
0.
So this is the difference, right? So no problem. I can run again. I think I already got this one, so you can just check. Really?
কে বলছে?
Car খিদা লাগছে।
Mute করে দিচ্ছে।
Anyway, so you already know this one, right? How many variables you have got? So 80%, definitely you are gonna get how much? You are gonna get 80% as the training data set, and you are gonna get 20% as the test data set. Now we are gonna predict our model using naive Bayes machine learning modeling. So how can we do this? Just a simple command maybe. So naive Bayes, so this is the command. Naive Bayes, you can see. You have to run this. You have to install a package. I already told you. So how I can do this, colleague?
Sir.
This is like the regression. I told you many times, and I'm doing the same thing during this week. Repeated. I am gonna repeat every time. I repeated these things. Anyway, what is your response variable?
Launch.
On data. And কোন data ক্ষেত্রে আমরা করছি? What kind of data? Train data. Train
data.
And here what you can do, you can use a kernel function. So yeah, this is the new thing. Like you have to know the theory of naive Bayes, and unfortunately I didn't give you the theory. First I tried with you with the practical things first. So I just tell you there are many kernel function for the input output relationship. So if you are going to give some input, definitely you are going to get some output, and based in the mechanism of getting output, in the mechanism you have to use some kernel function. So maybe I can use some kernel function. Use kernel is very important. I can give you one question in your exam. What is kernel function? So you can use the kernel function here, or you cannot use the result. You are going to get the result, no problem. If you don't use the kernel function, you will get the result. If you don't use the kernel function, also you will get the result. But what is the benefit of kernel function? You have to study by your own try. Anyway, it's not working. So could you please check?
স্যার এখানে একটা ডট হবে স্যার লঞ্চের পরে এই যে কমাটা আছে কমার সামনে একটা ডট হবে
Very good. Okay, let's try now. It works, right? So if we want to see the result, maybe we can just take a look, right? So you see the result is here. So there are some basic statistics and the rank. You see the rank is very important here. So could you please interpret? Could you please interpret this result? Try to interpret this one.
Sir, rank
Okay.
1.
I can give you some clue. So rankings, based on the ranking score, you have to launch your product, right? Either yes or no, right? So what kind of products have the probability, higher probability to get launched? Just this is the like clue I'm gonna give you. Okay, tell me.
2, sir. 50%.
1, 2, 3. Which one has the higher probability?
0.5.
0.425.
Really?
2 এ আছে স্যার 0.5
Oh
সেটা
my
rank
God.
rank
Why
মানে
you are
launch
talking
না
about
হওয়ার
here?
probability.
You have to take a look here.
স্যার র্যাঙ্ক 1 যখন হবে তখন এখানে
Rank
probability
1 product received rank
Sir,
1 score, launch
rank 1 এ 42%.
chances are very high. And the
Yes, sir.
product received rank 3. The chances
It's
high or
low.
low?
Low.
Yeah, exactly. Something like that. So yeah, this is the ranking mechanism, and maybe we can make a plot, similar plot. You can understand if you do the plotting. Okay, so how can we do the plotting here? You can just plot. What do you want to plot? Any idea? You can just plot the model. The model you just run. Okay, then you will have very interesting graph, I think. You see, the same thing. Rank 1, 1, 2, 3. Product, no launch and launch. So what is the ranking? Ranking 1, you see, and ranking 3 or 2 maybe. Anyway, so this is the same thing what I did before, right? So okay, so let's continue with the prediction. Predict. Okay, model, train, type is equal to, of course, probability. Okay, let's try this one. What problem here? No idea? No idea?
Quotation.
You can combine also. You can combine, combine. Then what P, the model you already, and the based on the train. Let's try this one. Maybe it will work. Okay, good. So what is the interpretation here? You know? Okay, think about this first row. First row. First row. What is the interpretation?
So launch probability. স্যার না লঞ্চ করার প্রবাবিলিটিটা বেশি।
লঞ্চ করার probability
না লঞ্চ না করার প্রবাবিলিটিটা অনেক বেশি।
based on what? Based on thickness, appearance,
appearance and spreading.
Anyway, I'm not giving you the answer, so I'm just giving you the clue. Maybe you can try later on. Okay?
Okay, sir.
No problem. Okay, let's try continue the prediction, do some modeling as well. Predict model, the same model based on the train. Let's see this one. What happens? I don't know. Okay, so tab. Just follow the command. You can try at your own. Tab table. The P1 I just created a few minutes back, and train of what? According to the launch. You have to fix launch. Okay. Can you interpret this one? 0 1 0 1. So this is like the confusion matrix. 0 1 0 1 29 1 9 39. Can you conclude this one? No. So this is the classification or misclassification. I can give you the clue. Okay. So if you don't understand, let's try with some.
launch.
Okay, let's try with some calculation. Diagonally, you have to do the diagonal calculation of tab one, which you just maybe tab only, tab 1 or tab. Did I use tab before? No. Did I use tab before? Okay.
No,
Yes.
sir.
I'm not sure, so I can use the tab here. Okay. 1 minus sum diagonal tab 1 divided by sum of tab 1. Okay. What is the value? I got
0.12820.
So if you don't understand the previous confusion matrix, I can tell you only 12% is the misclassification. Only 12% here is the misclassification. So what is the classification accuracy of from this model?
78%.
78%. So this is the interpretation. Anyway, let's try with very quickly with the test data. So we already completed about the training data. Now we can do the test data. So now we can previously we do the P1. Now we can predict based on the test data. So P2, right? So predict model. So based on the what data? Training or test? Test data. So you have to use this one tab. So here it will be tab 2, definitely tab 2. Okay, and it will be P2. It will be test launch. Okay, test launch. Now take a look. What problem? P2 predict model test table 2 table P2 test and launch. Okay, if you don't, maybe we can try with the same calculation again. I'm not sure it will work or not. Okay, so tab 2, right? Come. Good. So what is this interpretation?
26% misclassification.
And 84% classification. So misclassification is the in test data roughly only 14% according to the naive-based classification in R. In the train set, you can, but if you want to compare the train and test set, which one is best? Fitted naive bias, in which case test or training?
The training data.
Which one is more good? More classification you got?
The training data.
Training. Anyway, okay. If you want, then if you want to improve the accuracy of your model for the test data set, what you have to do? Do you have any idea? Suppose you got 80% accuracy right now. You want to increase the model accuracy more from 80% to certain amount. What you can do? Do you have any idea?
No idea.
By adding more observations. The answer is you can add more observation, you can add more variables, you can increase the sample size. Okay, anyway, so this is the class, this is the today's class. In fact, so we discussed about the naive based classification problem. So what is the idea behind the naive base? In naive base, what do we do? Mainly we classify. So this is a classification method based on what? Based on Bayes theorem. What is Bayes theorem? Bayes theorem is based on prior probability and posterior probability, right? And there are some rules and regulation we already discussed. What you have to do, we tried with the frequency table construction, we tried to calculate the rank, and if we tried to check the multicollinearity problem, if it is, you can remove or omit the ranking variable from your data set, right? So because our data set is a good data set, there was no multicollinearity found. That's why maybe the naive base work good and the misclassification is near about 14-15%, and the classification accuracy is more than 80%, right? So this is the way. So the normally, how can we predict? How can you predict something based on the machine learning algorithm? So there are some rules. The first one, you have to split your data, training and test. You have to predict the training data set. Also, you have to predict the test data set. And finally, we classified whether our product is launched or not launched, and what algorithm, good fitted algorithm here. We have just only used naive Bayes, but we found naive Bayes the accuracy is good. So what you can do, you can compare other algorithm here. You can do the same thing with KNN, maybe K nearest neighbor, then you can check which algorithm is the best fitted algorithm here. So based on the problem, based on the nature of the problem, you have to apply different kinds of algorithm, and finally you have to check which algorithm fits good to your data set for the prediction purposes. So this is all about the naive Bayes, like naive Bayes description or mechanism, right? So I think I'm not sure about you, but you can just try in your home. I can give you the codes and data so you can practice. Try to learn some theory as well, how naive Bayes works. Okay, what are the assumption? What are the mechanism, right? So in the next class or maybe in the upcoming classes, we can talk about the Bayes theorem. In one class, I'm not sure about the next class. In any of the class we are gonna take, maybe in that class we can talk about the naive Bayes theorem, right? So this is all about today's class, and the class was about naive Bayes. I think you enjoyed my class, and try to practice in your home to learn more and more. And if you want to have a clear idea, there is no alternative of practicing or learning by yourself, right? Thank you. So do you have any question?